Welcome to this explainer. For decades, the absolute biggest bottleneck in computing was, well, us. Machines literally had to just sit there and wait for humans to manually type in data. But that era is effectively over. Today, we're exploring the architecture of recognition systems, the incredible technology that allows machines to bypass the keyboard entirely and actively read the physical world on their own. The paradigm shift here is absolutely total. We are eliminating the keyboard and equipping machines with specialized automated senses. We're teaching them sight through light and vision, proximity through radio waves, and identity through human biology. Let's look at how these inputs actually function out in the real world.
Okay, let's dive right into this. We're going to take a quick sensory journey through the machine's brain, starting with machine sight, moving into proximity, then identity, and we'll wrap the whole thing up with a recognition system toolkit.
So, number 1, machine sight, reading with light.
The foundation of machine sight is optical mark recognition, or OMR for short. It relies on this beautifully simple mechanism, basically just detecting the presence or absence of a mark. As a scanner passes light over a form, timing marks on the edge tell the system exactly where to look. Then it just compares those marks to a stored template. It's exactly how schools grade those multiple choice exams in a matter of seconds.
Now, what's really fascinating here is the trade-off. On one hand, OMR is incredibly fast and highly accurate, with zero manual typing needed. But its fatal flaw? Structural rigidity. It is completely design sensitive. A poorly printed form will just break the system. And because it's strictly limited to predefined boxes, it can't read a handwritten message. It's practically blind to anything outside the bubble.
So how do we move from simple pencil marks to reading actual, complex text? Well, that requires a more advanced sense, optical character recognition, or OCR. Let's walk step by step through a massive real-world application of OCR that you've probably encountered, automated number plate recognition, or ANPR. It happens in 4 stages. Step 1 is detection, where a sensor spots the vehicle. Step 2 is recognition, where it isolates the plate and turns shapes into text. Step 3 is action, verifying the data to trigger a real-world event. And finally, step 4 is exit and payment, finalizing the transaction.
And this brilliantly illustrates how those 4 steps actually play out in a parking garage. An infrared sensor spots the car. The algorithm isolates the license plate, chops it up into characters, and uses OCR to translate those physical shapes into digital text, like 1ABC234. A database verifies this in real time, instantly triggering the barrier gate, and ultimately calculates the stay for payment. Zero human data entry required.
However, it's absolutely crucial we look impartially at real-world performance here. ANPR is an incredible 24/7 automation tool for sure, but it has distinct vulnerabilities. A simple layer of mud can completely blind the camera. Furthermore, criminals can exploit this by cloning plates to trick the system entirely. So, the machine's eyes are powerful, but they definitely lack human intuition.
Moving on to number 2, proximity, reading invisible data through the air.
The core technology here is RFID, which reads data using radio waves, meaning no direct line of sight is needed. But notice how the power source changes literally everything. Passive tags have no internal battery, they're cheap, dormant, and perfect for encrypted passports or your everyday credit cards. Active tags, on the other hand, pack their own battery, actively broadcasting a signal up to 50 meters away. That extra power means a farmer can track roaming livestock, or you can scan an entire warehouse of pallets in one single go. If we map this out on a proximity scale, active RFID dominates that 50-meter long range, while passive RFID handles the middle ground. But right on the ultra-short end, we have NFC, or near-field communication. It's a highly specialized version of RFID that only functions within 0 to 5 centimeters. Because it requires intentional, super close proximity, NFC is basically the engine behind our daily digital interactions. It operates in 3 main ways: peer-to-peer, for instantly sharing photos by tapping phones; read-write, for tapping a poster to open a web link; and card emulation. It's kind of wild to think about, but you are literally tapping into the machine's proximity senses every single time you buy a coffee with your phone. All right, number 3, identity, biometric recognition. Now, what's really interesting about this is the biological difference between the 2 main types of eye scans, because hackers absolutely cannot fake these patterns. On the surface, we have the iris, that colored ring at the very front of the eye, but deep inside, we have the retina, a complex, totally unhackable web of blood vessels located at the very back. How a machine reads these two areas completely alters the user experience. Retina recognition requires a specialized beam of light to see all the way into the back of the eye, meaning the user has to sit perfectly still. It's slow, so it's strictly reserved for things like bank vaults. Iris recognition, however, uses a standard digital camera with infrared light to just read the surface. It verifies identity in literal seconds, which is perfect for keeping thousands of passengers moving quickly through airport immigration.
Finally, number 4, your recognition system toolkit. Let's put it all together.
So, the crucial point is synthesizing everything we've just learned into a toolkit, where the overarching theme is minimizing human effort. With sight, OMR, and OCR, effort drops to 0, as cameras handle high-volume data on their own. With proximity, effort is incredibly low. It's just a quick tap or simply walking past a sensor for seamless tracking. And with identity, well, while human effort slightly increases because you have to scan an eye or fingerprint, the payoff is absolute, unhackable authentication. We've built an incredible infrastructure where computers are actively reading our physical world. They grade our papers, raise barriers for our cars, process payments through thin air, and perfectly verify our biology, which leaves us with one final fascinating thought to ponder. If machines can already perfectly see our marks, feel our proximity, and identify our biology, what sense will they master next? Thank you so much for joining me for this explainer, and keep observing those invisible systems humming all around you.